Yes, you are. Very
We're live.
good. Okay.
But that's okay. This is hilarious.
I have the cutest dog.
You really do. Don't tell Carla, of course. Pamela said she has the cutest dog. Wrong, says Carla. Hey, everybody. We're here on time. We thought we were going to be late, but you made it.
I did. Yeah, I left our new offices. Cosmic Quest moved into new offices upstairs from an amazing restaurant. But that's neither here nor there. I got to the parking lot and my car was completely blocked in by people who were illegally parked. It was it just sort of
That's really
like,
cool. You should share some pictures of the new office at some point.
yeah,
Or
it's
maybe you already
once we're
have, but
no, we haven't. We're waiting to like get all the furniture. So currently we have desks and it looks like an IKEA showroom, but not the part where it's made to look like people live there. The part where it's like pick up furniture and carry it
just
away.
piles of boxes.
Just like blank assembled furniture.
Right.
Actually, it's the
Right.
yeah, and all of our furniture is from IKEA, so there's reasons it looks like that.
Yep. That's from IKEA. So,
Yeah, I have the exact same set of
yeah.
shelves over there.
Yeah. That used to be the kids. The kids had their own separate shelving units, and then I took them. I stole them from them. So this is cool. So you know what a Trappist beer is, right?
Yeah,
So Trappist beer is a For those who don't know, Trappist beer is a
they're
Belgian
awesome.
beer, or it is a beer made by the Trappist order of monks in Belgium. So I've convinced my local brewery, or we're in the process of convincing them to make a Trappist, a double, essentially a Belgian double, and we're gonna have a Trappist one party here in town. So we're gonna invite. I'm buying or Universe Today is buying like a keg of beer, and we'll consume that until that's gone. So
That is
yeah. So if you
awesome.
live on Vancouver Island, or you want to attend, reach out to me and I'll hook you up. Probably in the next month or so. So anyway,
That that is quite cool.
yeah, it's fun. It's there's actually a pretty good science community here in Courtney, and I'm pretty low um, profile, and I think I'm
Uh-huh.
going to try and sort of just have some more fun, you know, with the science oriented folk here, and even in my hometown. It's a pretty small
That's
town,
cool.
right? So,
Yeah, yeah.
but there are a lot of people, and apparently a bunch of people are fans. So I run into them every now and then, which is great.
I
Um,
I've run into that in the grocery store, and it was one of those
yeah,
times where it's like I'm in leggings and a
yeah,
biking shirt and don't want to be
yeah,
recognized.
exactly. Yeah. Anyway, but I was even thinking, like, like we could get some speakers to come in, because I got so many great friends, right?
Hmm.
You, Paul, Matt Sutter, things like that, and get them to come and just do a talk here in town, and we'll take you skiing or take you out in the out on the ocean. But anyway, um, okay, let us first say hello to a bunch of people who are rolling with the punches and are here at this weird time, weird place. So I'm going to say hi to Adam Synergy and Boric Klankar and Brian Cordova and Carolyn B. and Dak Tazoo and Elad Avron and Fleming Thunberg and Gordon Dewis and Guido Bibra and Helge Bjerkog and El Torture and John Suffield, Jordan Young, Lillian Brandon, Michael Meyer, Nelson Cruz, Paul O'Neill, Arinstro, Robert Scott Herrick, S. Wolberg, Sean Kennedy, Tak Tang, the Stealth DJ, Tom Van Scotter, Tony Raggett, and Jonas Sofri. Hey, everybody. Welcome to this impromptu, strangely timed Astronomy Cast.
Yes.
Um, so, if you have no idea what this is that you have stumbled into, this is going to be a live episode of Astronomy Cast. We're going to be talking about magnetic pole reversal, Nibiru,
No.
cataclysmic, no, solar flares. No, we're just going to talk about the magnetic pole reversal, which is actual science
Yeah.
and fits nicely into our idea of destroy and rebuild, because literally one then the other will happen in the context of our planet's magnetic field. Anyway, we'll do that, and then we'll stick around and answer your questions about space and astronomy, and then Pamela will prepare herself for another journey. Where are you going now?
Yes, I'm just gonna go meet with a couple of collaborators, and we're gonna lock ourselves up and work on writing a document for 2 days.
Right on.
Yes,
That's the best kind of writing when you lock away the
it's
world.
with good humans.
Yeah.
It's with
Oh,
good
good. Good.
humans. So,
Um, and for anyone who's looking for like a project to do, we're going to be the mega movie, the Eclipse mega movie.
yes,
So Astronomy Society of the Pacific, and I figured, and have they talked to you at all about that? Have they
I
prepped
have
you?
an email I've been ignoring because of this document I have to write, but I do know about the mega movie, so you can ask me questions.
Well, we'll talk about it in Astronomy Cast, so we can help them get
Okay.
some additional love out there. Which is,
Okay.
that I mean, the thing is that I am super torn about this because the best advice that I've heard is when you watch your first total solar eclipse, you shouldn't try to take any pictures. You should just stare into the sky with your protected eyeballs and watch the eclipse, and that anything else is just going to rob you of the experience. And that's my plan. But yet there's this such cool project to connect together thousands of amateur astronomers taking, thousands of pictures into this amazing high resolution movie that will show the eclipse moving from place to place across the continental United States.
So, so my take on that is this is what timers were set up for and what
Yeah.
auto series was set
Yeah.
up
Yeah.
for.
Yeah.
So you practice the day before and then just set your thing so it just
Yeah,
does
it goes
its
and then you go do something else. Yeah, like
yeah.
watch with your eyeballs. Anyway, we'll talk about that in the intro to the actual episode. But
Okay.
um, Astronomy Society of the Pacific, I guess, is the place to go and take a look. We did an article on Universe today about that, but I'm
And the mega movie stuff is actually being done by the University of California Berkeley group with
and
Laura Petikalis.
Google. Yeah.
Yes.
Okay. My intro's ready. Recording software is ready. Is your brain ready?
No, I need to close Slack. We're doing website updates today and I'm watching my programmers and I just need to stop doing that. Okay, now I'm ready.
Say when.
I am pressing record. It is recording and it seems to be doing everything correctly. Hello, Chad.
Hello, Chad. Okay. Here we go. Astronomy Cast, episode 442, Magnetic Pole Reversal. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, the Director of Technology and Citizen Science at the Astronomical Society of the Pacific, and the Director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing?
Fantastic. Just a big reminder to everybody, of course, the eclipse, 2017, August this year. If you're planning on attending, there's a really cool project that you're going to want to get involved in called the Eclipse Mega Movie, and it's sort of a collaboration from the Astronomical Society of the Pacific and Google and Berkeley, I think, and they're going to have amateur and professional photographers across the United States, across the eclipse line, gather together and take a bunch of pictures and then merge those pictures together into one mega movie that shows the whole eclipse. So I'm going to be doing that.
And there's a lot of cool science that can come out of this from basically depending on where you are, you can see how the light is getting refracted based on do you see Bailey's beads? Do
Yeah.
you see what are the nuances of how you experience the eclipse? And we're going to be able to catch that and do that science.
So if you're planning on seeing the eclipse, not necessarily with us, but anywhere across the U.S. when it happens, and you think you've got the right gear, like a DSLR and a reasonable lens, then do a search for Eclipse Mega Movie, and you should be able to find the project and sign up. All right. So if we look back into the geologic record of the Earth, it appears that our planet's magnetic field flips polarity every few 100,000 years or so. Why does this happen? When's it supposed to happen next? Is it dangerous? All right, Pamela, set the stage. What is okay? Earth magnetic field. Let's start there.
Yes.
The
Okay.
Earth is a big magnet.
Sort of. So magnetic fields are generated by lots of different things. And one of the easiest things to make a magnet out of is flowing current. This is an electromagnet. We've probably all done this at some point in school where you take wire, you wind it around your fingers, you run electricity through it, and suddenly you can fling paper clips at one another. This is what you do with electricity in middle school. Now, with the
You
Earth,
build an
we
electromagnetic railgun. Yeah.
exactly,
Okay. Yeah.
exactly.
Yeah.
This is the purpose of science class in middle school to
Sure.
build
Of course.
weapons. So our Earth doesn't exactly have wires attached to a battery, but what we do have is molten metal. And molten metal has lots of readily flowing electrons. That's a fancy way of saying current. And thanks to convection, this molten metal is looping through the interior of the planet. And this process is, we believe, generating our Earth's magnetic field. Now, for reasons that we don't fully understand, at a rate we don't fully understand, the magnetic field of the Earth turns itself inside out and realigns so that what was once north becomes south, what was once south becomes north. The land stays put, but the magnetic field lines reverse so that your compass is now pointing in a different direction.
Okay, you went straight to the reversal. That's fine. That's fine. Go ahead, jump forward. Spoiler alert. But okay, so I guess so. It's the rotating metal. It's the moving molten metal at the core of the Earth that is generating this magnetic field and aligning with essentially the rotation of the planet, but not quite. The
Yeah,
exact
it's the
spot.
convective.
Right.
It's the convective motion of this circulating.
Metal.
Yeah.
Molten metal. Yeah.
Yeah.
So and of course they don't line up, right? The point where the Earth's actually rotating and the point where the magnetic North Pole is are actually in two different locations. And in fact, here in Canada, we own the pole, the magnetic North Pole here in Canada, and we track its position and it's moving.
It is.
Yeah.
And what's amazing is while over the course of our lifetime we've been able to see it move several degrees across land, there have been points in history where looking at how the magnetic fields trapped in lava rock has recorded that changing magnetic field. It looks like at some points in time it was moving as fast as 6 degrees per day.
Wow.
Yeah. Yeah.
Now, we haven't been around for a long time, and we definitely haven't had the ability to measure the event, the magnetic field of the Earth. So how do we measure, or how do we know the strength and location and position and polarity of the magnetic field into history millions of years ago?
Well, it actually is fossilized. In fact, it's fossilized more readily than critters are fossilized. And this is because the minerals that come out when volcanoes erupt, when the world parts and new land is created at the mid ocean rift, that lava has magnetic particles in it that will align with the Earth's magnetic field. And as the lava cools and becomes rock, it freezes
Oh,
in
that is so
that
cool.
alignment.
That's amazing. So that you've got this fresh lava that's coming out of the Earth. It's got little tiny iron filings, little magnetic particles
Yeah.
in, that are forming. I mean, rock forms crystals, right? Metal forms crystals. You've got these little particles inside the lava, and they are lining up with the magnetic field lines of planet Earth before the lava cools, and you've got this record of the magnetic field, the strength, the direction, the position as this lava is flowing out and cooling. That is one of the most amazing sort of geologic discoveries that I can imagine. It's
And
beautiful.
what's super cool is this provides a different way to see how our earth has changed over time and to track things to different points in time, because we see the same reversals creeping up across the entire planet, and it's the set of, well, for this many tens of thousands of years it was aligned in this direction, and then for this entire million years it was lined up in this other direction, and then oops, for 450 years we're going to point this way. And so, just like the rings of a tree have patterns of sometimes thick, sometimes thin, but the rings themselves go all the way around the tree so that you see the same thick on either side if you take different samples. Well, it's the same thing with the magnetic stripes of alignment across the planet. And so we can
Right.
look at the various places where a planet is forming new land over long periods of time and see, well, this stripy section, this corresponds to 300,000 years ago. This stripy section corresponds to 800,000 years ago.
And then you check multiple lava flows on different parts of the world, and they all line up so that they are duplicate records of each other, but they're showing it from the different perspectives. So you're seeing, for example, the one in the South Pole is indicating the exact same thing that the North Pole is seeing, but it's seeing it from the reverse perspective because it's located on a different planet part of the Earth. It's
Well, and
it's
and
amazing.
another part of this that's super cool is you have the stripes getting formed, and then the land that they're forming on is moving. It's that whole continental drift thing that we talked about in
Yeah.
the last episode. And we can see essentially the stripes drift off and rotate,
Yeah.
and we can put back together what things looked like at different points in time by lining the stripes back up.
Right. So not only can you get a sense, this confirmation, but you can then run back through history of the motion of the planet and see how, you can tell that this thing should have been aligned. If the continents weren't moving, then it should have been aligned this way, but because they were moving, it's off by 5 degrees or some amount, and you can literally then use that to just run a completely independent way of tracking the motion of the continents in the past. Again, this process of measuring the magnetic orientation of the lava is one of the most incredible things inside. It's as fascinating to me as like spectroscopy. How you can like blow up the lines, the chemicals in a star and
Well,
detect planets orbiting around them. It's this precise, amazing science. So volcanologists, geologists, kudos. You are amazing.
Well, it took them a while to get there because this is one of those discoveries that when it was first made, everyone was like,
Yeah.
who cares?
Whatever.
It was first noted back in the 1920s when people were starting to get into dinosaurs, the competitor to astronomy in
Yeah,
terms
of
of great
course.
sciences,
Yeah.
that all of the rocks they were seeing from the early Pleistocene were magnetically aligned the opposite of what was experienced currently or currently for the 1920s. And as people started thinking about the Earth's magnetic field, they started noting in the 50s that the poles seemed to be wandering and there
Mm-hmm.
seemed to be tide to continental drift. And it was just sort of like,
That's funny.
interesting.
Yeah.
Yeah. And it was only in the 60s that people started to really take a look at this and look at the banding and map out these changes and notice basically the fact that the Atlantic Ocean is striped with alternating magnetic fields. The bottom of the Atlantic Ocean, which has been forming over time, is this amazing record of all of these fossilized changes. And it took essentially 40 years from the notice of, Pleistocene fossils are reverse magnetic field to 1960s of realizing exactly what this implied.
Right. That the magnetic field lines flip polarity on a random time scale, and that this has happened many, many times in the past. And what you thought used to be the North Pole used to be the South Pole. And so if I did literally have a compass, and I'm, 1 year it's pointing north, and then the next year it's now pointing south, like it's worthless now.
Well, it's not worthless. You just have to realign
Just
yourself.
look at it backwards. That's all.
And that's okay.
Yeah.
Just stick a new sticker on. But the
Repaint the little
exactly.
the little blob on the front that says
Why not
north.
recycle?
Yeah.
But I mean, the idea that it takes just 1 year and it's going to be a nice clean
Yeah.
sweep.
How long does this take?
No.
All right. Let's talk about this reversal. How long does it take for this reversal to actually happen? So from when I'm firmly North Pole to firmly South Pole, how long does that process take?
As long as it wants to.
How long has this process taken in the past?
So this is the crazy thing is this is a fairly random process that people have been trying to find patterns in, and they're just not really succeeding, where there appears to be evidence that some of the reversals took less than a human lifetime. In one case, it looks like it went from north to south to north again within 450 years. But in general, it's a process that is thought to take, in most instances, but not all instances, between 1,000 to 10,000 years. But like I said, there's evidence that at one point in time, and it's actually evidence in your neck of the wood, lava flows in the American Northwest, where you had 6 degrees change and where the pole was each day.
Right. And even we'll get to this in a bit. But so what is going on during that time that it is changing? Is the pole, now the pole is at the 49th parallel, and now the pole is at the equator, and now the pole is, or do they just realign instantly? On the sun, you get these magnetic field lines are coming out of sunspots, and then they get all tangled up, and then it just snaps and they reconfigure into a new configuration, and it's back to business as usual. Is that what we see, or do we actually see
Pretty
the pole
much.
move over to its new location?
So in general, we see this long-term excursion of the pole is the way we refer to it. The pole
The pole
wanders.
wander,
It's
yeah.
not set in where it
Yeah.
wants to be. But with the geomagnetic reversal, it is very similar to what the sun does, where it essentially turns itself inside out. You end up with multiple field lines poking through the planet in different places. It acts like there's multiple north and south poles at the local level if you're walking across the surface of the planet. And there is magnetic chaos. It's not that there's no magnetic field, it's that there's a chaotic magnetic field. And one thing that is very different from with the sun is the magnetic field appears to be weaker during the period of reversal. So you end up with this chaos of lower magnetic field, multiple poles, the field lines kind of tangled up and sticking out in all different directions. And then they settle themselves out with the pole in the opposite orientation.
Now, as I recall, the magnetic sphere around the Earth is important,
It is. It
right?
really, really
Which is,
is.
we always talk about going to Mars. The big problem with Mars is that there's no magnetosphere, and so if you go out and stand out in the environment, your whole body will erupt with cancer and you'll die.
So
So, okay, maybe not that quickly, but it's very, we want the magnetosphere here. Without it, life on Earth would be lethal, right? Being out on the surface of the Earth
yes.
would be lethal with the amount of
And
radiation out
this
there.
is a weakening of the magnetic field, not a destruction of the magnetic field. And so there are some interesting side effects. You would get solar auroras at different latitudes than you currently see them. Uh, but while getting auroras at mid latitudes is awesome, you still have enough magnetic field that we don't die. And this is stood up for in the fossil record. We can go through and we can look at various parts of the planet and go, over here says there was a reversal, over here says there was a reversal. There was a reversal everywhere, and no death, because we don't see die-offs in the fossil
Right.
record that are punctuated at the same times as the magnetic field reversals.
While we do, for example, see great die-offs when there
Oh
were
yeah.
super volcanoes, when there were Armageddon, asteroids, events like that
Yes.
clearly caused great die-offs. But in this case, we know the moment, the 1,000 years, the 100 years, the couple of years when this reversal time was happening, and we don't see total catastrophic death of all life on Earth.
Exactly.
Whew.
So it appears we're safe as long as there is a magnetic field. It's when the magnetic field goes away that we're toast. But while it's simply weak, we just get different forms of aurora.
Okay, I mean, everyone loves auroras, and I know you folks in Florida are missing out on a really big aurora, so this will be for you. But
Yes.
would there be, I mean, it feels to me like there still would be like some kind of increase in radiation. Like it wouldn't be, it's not as, a nicely well aligned, fully operational magnetosphere is better than a chaotic, flippity floppity magnetosphere, right? Like we
We
want the
we
former, we don't want the latter. It's not
there
ideal.
will be an increase on what particles can get through. There will be an increase on how the solar wind affects the atmosphere, but it's not death. And the not death is the key part here.
Okay. So there you go. Now, when did the last one happen?
A little over 700,000 years ago.
And how often does it happen?
It's estimated over the long and fairly random process that about every 300,000 years.
Huh.
Yeah.
So we're due in the,
Well,
and this is where we have to go back and reference a previous episode that we just did about how, there's no such thing as we're due. But
and
are we
and
due?
it's so this isn't one of those processes that you are so there's processes where it happens regularly at this interval, and just like the mailman,
Cicadas.
yeah, cicadas,
Yeah.
7 year
Or the
cicadas.
the sun's polar reversal.
Right. So there's certain things that have a known periodicity, and when they're delayed, each day that you're not seeing them, there's each minute you're not seeing the mailman, each day you're not seeing the 7 year cicadas that are due that year. Yes, they should be hatching
Yeah,
imminently.
those cicadas are going to be popping out any day now.
Right.
Yeah.
Now, this is a weird process. There's like this period where for like a million years the magnetic field did absolutely nothing, followed by zip 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 back and forth. Can't decide what it wants to do, and we don't know why. And we can build computer models that replicate what's going on, but it's a sufficiently chaotic process that while we can replicate getting a solar dynamo, and not a solar, getting a magnetic dynamo, getting the pole reversals out of this convection of the liquid iron in the Earth's core, um, we can't say yes on August 24th, 3 days after the solar eclipse, the Earth's magnetic field will reverse. We can't do that.
Right, right. And so to say that we are overdue, we could be overdue forever. It may never flip again. and it may flip
we're pretty
seven
sure.
times in the next
Yeah,
1,000 years. We
yeah.
don't know. But if it was going to flip, or we thought that it might be in the process of flipping, what are some signs that we might see that it was underway, or that it was before being underway? What would we see?
So as near as we can tell, there's an overall weakening of the field, uh, and then you end up with this effect of basically multiple magnetic field lines coming out through the surface, acting like here's a north, here's a south, where you have the field lines cutting through. So think sunspots,
Right.
except now we're trapping magnetic field in all of our little magnetic field detecting equipment on the surface of the planet. Um, it's going to be the kind of thing that sort of is like, huh, magnetic field seems a little weak. Let's keep an eye on this. Huh, there's a magnetic field poking out of Siberia.
Yep.
And oh, wait, we have magnetic fields everywhere now. So it's the kind of
Right.
thing that will sneak up on us.
But isn't one of the signs that we would, theoretically see the pole wandering pretty quickly?
Yes. So that's one of the things that happens in some cases. But if it's going to be a 10,000 year flip versus a
Right.
couple of year flip, this is something that acts however it feels like.
But don't we see our pole moving pretty quickly right now?
And this is where we have two different things that we have to worry about. One is the excursions where it's just simply wandering about, and the other is the and now I shall reverse.
Right.
And we don't know
Which one it
until
is?
you get the yeah.
But we are in a period. If I recall my reporting correctly, we are in a period where our pole is moving pretty rapidly,
It
unusually
is.
quickly. So
But that doesn't mean it's going to reverse. It doesn't have to. It can do what it
it can
feels
do what
like.
it wants, and it doesn't matter to us or the compass companies.
Magnetic field don't care.
Let's talk about consequences then. So let's say, we talked about the radiation, that our need for a magnetosphere. Birds appear to navigate by the magnets in their heads. Would they have a problem?
Yeah. Well, so here's the thing. We do have the whole no death in the fossil record. That doesn't mean you don't end up with things deciding, and I shall nest over here now because my magnetic field sent me somewhere totally different. With the gradual processes that we see now, generation after generation, the birds are able to figure out where they're supposed to be. We don't have the swans, the sparrows, the whatever birds radically changing their nesting sites due to magnetic wander. Um, we do have them moving because of human beings. So, looking at all the impact factors, one generation of birds to the next can figure out, oh, I now need to navigate slightly more to the left.
Right.
So it's life is a way of adapting.
Right. So you might have a generation of birds that's completely confused, goes in the wrong direction, and
Finds a
suffers,
great new nesting site.
or suffers a
Yes.
terrible die off. But then you're going to see a follow up generation, the ones who, will evolve the correct direction, and within a few generations they'll be back in business, and now they're going to have upside down compasses in their heads.
And while we may end up with some critters that struggle due to these navigation issues, there is no evidence, and I'm just going to keep saying this, there is no evidence for massive die-offs
Right.
tied to magnetic field reversal, and the actual planet just keeps
Right.
spinning in its
And
normal
and we
orientation.
can't find evidence of confused birds.
No,
Right.
no, that's probably a little too fine-grained for the
Yeah.
fossil
Yeah.
record.
What about our technology?
Yeah, that's a different problem because life hasn't been as technologically evolved at any point when there's been a past reversal, and we use
Mm-hmm.
magnetic fields a lot. Now, GPS satellites do help,
Yeah.
but
So 50 years ago, a worldwide just, jumbling of the magnetic field would cause total chaos to our navigation system. Airplanes and boats. Now they all have GPS, so we're kind of protected, right?
We're a little bit better off, but you know, those spacecrafts still we use the Earth's magnetic field to push against for a lot of spacecraft. It's part of how they do their navigation thing. And so you start having difficulties with how we handle spacecraft if we have a significantly weakened field that you can't push as hard against. Um, so I think we're going to find that there's a whole lot of stuff we hadn't really thought through how much it relied on the Earth's magnetic field
Yep.
if that field suddenly is a lot less intense.
Right. So, in conclusion, the Earth's pole flips every now and then. We don't know why. We don't know when it's going to happen. We don't know when it's going to happen next. It's probably all right. Don't worry about it.
But it'll be a bad generation or so.
Yeah, but it's fascinating. Thanks, Pamela.
Yes, my pleasure. And now we save. This is 442.
Mm-hmm. Export and then upload. Whoops. Man, So I've figured out the solution to Dropbox. Don't install Dropbox on your computer. You just
Yes.
use the web version to do it. That's what I do, and then that uploads more properly, more better. Okay, so from Tony Reggett, why does Pamela's face always light up when she's talking about death and destruction? What's that about, Pamela?
I don't know.
Why do you find the misery and mayhem so entertaining, you monster?
I just like to see things like it's hitting the reset button on the video game and getting another try to get a better score than you got the first try.
Psycho. Okay, let's move on. Steve Chisnell asks, didn't a solar flare knock out the Quebecois electrical grid once in the late 1980s?
Yeah.
Sure did. Yeah.
That was amazing.
Yeah. I mean, it tried to knock out the entire electrical grid of the
America
whole
Northeast.
Yeah, the whole northeast of the United States, and the whole thing shook and almost went offline, and it found the weak point in Quebec. And in the winter time in Quebec is not the time you want your electricity to go out. It was a bad scene for a while, and this was a teeny tiny version of course, the big event that happened in the 1800s, 1859, the Carrington event.
Yeah.
And in 2012, a solar storm of the same power or stronger than the Carrington event went off the sun, but wasn't headed towards Earth. And so we watched it go sideways. So it's just a matter of time before we get a Carrington event class solar flare hit us here. And you can tell I've just done a video on this. And back in the 1800s, it lit telegraph towers on fire.
Oh, yeah.
It was a really bad scene when it passed through, our neck of the woods. Auroras in Cuba.
Part of the reason this happens is it sets the Earth's magnetic field oscillating. And when you get an oscillating magnetic field, that drives electrical current. And if you drive too much electrical current through a telegraph wire, it lights the poles on fire because of all the heat. So if you think about it, electric heaters are just wires that have too much current put through them, so they heat up.
Yeah.
And the reason electric heaters will sometimes light your house on fire is they heat things up too well. And yeah, so they just turned the whole telegraph grid
Yeah.
into an
Totally.
electric heater.
Um,
And yeah, my face does light up when I
yeah.
start
Brian
talking about destruction.
Cordova says, I feel that I don't really understand fields in general and fundamental, and they're so fundamental. Would you consider doing an episode on fields in general? Yeah, I mean that would be fun. The thing with field, I mean the first
That
thing,
would
right, is that even
that would be
just,
super hard.
well, yeah,
Yes, we can do it.
we can, right? But like the first thing we need to do is tell you how your entire life is a lie. That what you think is matter is really fields,
Oh,
quantum.
you're thinking
Well,
waves. No,
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 that,
no.
that
You're
no
thinking
that that
waves.
that that matter is, quantum fluctuation fields across the entire universe, probability functions that line up. That what we think are elementary particles. They are not little balls, collected together into larger objects. They're, at a fundamental level, just the nature of matter and energy itself. That matter
Just
and
despite
energy are interchangeable. Like, you don't want to take is it the red pill? Anyway, one of these pills. If we go down that path, the quantum fuzz of existence will blow your mind. So, but we can do that and then talk about fields in general, right? As a relation to that. Um, it's super fascinating, but it is just, I mean,
so we do need at least one more destruction of the earth topic
yeah.
for next week before we do fractals for 444.
Fractals. Okay. Yeah. Anyone got a topic? I had one. We'll think of it. We've got a little time.
Okay.
Steve Chisholm wants our reactions to the news about moving the manned flight of the Orion spacecraft to 2019. Elon Musk announcing the lunar flyby in 2018, and what Steve didn't mention was that Musk has pushed back the Red Dragon trip to Mars to 2020. So that's been pushed back 2 years. So let's take them in order.
So
Go
I
ahead.
have to apologize. Last episode, I was like, no, it won't be commercial people. I was wrong.
Mm-hmm.
Yeah, I was totally wrong.
Yeah. So as you
I'm deeply
recall,
confused.
last time that we were doing Astronomy Cast, just a couple of days ago, um, Elon
The
Musk
announcement came out while
stole
we were
our
recording.
thunder and announced the human moon mission during the episode. So what do you
Yeah.
think? Two private astronauts paying, I've heard estimates of 175 million each to go on a
Yeah.
trip around the moon and back.
And it's going to be a fully automated spacecraft. So they just have to sit there
Yep.
and sit
And,
there.
and enjoy the ride.
Yeah.
Yeah.
Take
Yeah.
photos.
How long will it take? About 7 days, right? Take about a week?
It depends on what orbit they're using. I don't know. It took a lot longer than that to get to the moon the way we used to do it.
Did it? No. It took like 3 days to get to the moon, 3 days
You're
back.
right. You're right.
Yeah, no, it was about a week. And then there's
Yeah.
like a free lunar return trajectory that you can take. I forget. There's one that you can do in the Kerbal Space Program that'll bring you back home. And so you're looking at about a week of puffy face, messed up eyes, but you get to grow an inch for these two astronauts. So I mean, what do you think? Is this a ridiculous, frivolous use of technology and money, or is this super cool?
It's proving a concept. So if it was NASA doing it, I'd be kind of pissed off because it's super expensive to send human beings into space, super expensive to send humans into space. And so I'd want humans who are doing science and things or building things or accomplishing things.
Mm-hmm.
And if we're just doing a technology test, do an unmanned tech test. Well, Elon Musk is essentially doing a tech test. He is proving that the Red Dragon can happily do its thing, go out past the moon, come back again. Um, and he did this once before with a wheel of cheese,
Yeah, so
not
instead of
past the
cheese,
moon.
he's putting,
Yeah.
I mean, he put 2 astronauts worth of cheese on the Dragon capsule.
And this time, instead of cheese, it's going to be humans. And there is actually a difference. Um, so he's doing a very expensive tech test, and it sounds like the humans are paying for their own way. And so I can't complain. I can just sort of be like, please don't do it. Do something bad. Please don't do something bad, because that leads to additional FAA regulations. And really, we don't need more regulations.
So, so
Don't screw it up for the rest of us.
yeah, like don't kill them,
Yeah,
right?
it's a
But I mean,
goal.
if they want to pay money to help cover the costs of improving the technology of human spaceflight,
Yeah.
let's do it. And I dare you to tell me why should we bother doing this when there's too many things to fix on Earth? I dare you. All right, because I'll go off.
Did you see the meme that was going around that was basically bad things happen, bad things happen, bad things happen. 7 days later, NASA announces new habitable worlds found.
Yes, yeah, I saw that. Yeah, yeah, yeah. We're out of here.
Yeah.
Um, Steve Chisholm also just said, hey, for the Earth's destruction scenario, what about the mega tsunami that could be triggered by the collapse of La Palma, the Canary Islands? I just did a search. We haven't done an episode on tsunami. So
Let's do
let's do
tsunamis.
tsunami. Got that,
I'm
Susie?
a fan of
Yeah,
that.
of course you are, because there's so much death, you Grim Reaper. So we'll do tsunami and both kind of regular tsunami, and let's also do collapse, mega tsunami from collapse and from asteroid strikes. So
Okay.
that sounds great. Um, okay. Well, there were some other questions here. Uh, so let's talk about the other part of his question. Then let's talk about the Orion capsule and putting some astronauts in that.
So that's the
Yeah,
SLS.
yeah. So
And
an upcoming launch of the SLS.
yeah, so I haven't been following that one enough. What are they launching it on?
Well, it's going to be launched on the SLS, right? So it's going to be the new
Okay.
Orion capsule launched on the SLS rocket, which is of course the
Lockheed, Boeing,
yeah,
somebody
it's the biggest
else,
rocket ever
combined
built right
endeavor.
now. When that thing
Yeah.
launches, it is the spiritual successor of the space shuttle. It is an enormous Saturn V type rocket with 2 solid space shuttle boosters bolted
And this
onto the
is
side of it.
developed strictly with governmental funding for the most
And
part.
it's NASA. Like, I don't know if you recall back in the day, and I said, they'll never be able to cancel the space shuttle because they've got tens of thousands of people that work on the space shuttle, and those people will no longer have jobs. Well, head fake, they build a new massive rocket, and that's where all those people are working right now.
Yeah. So this is the consortium is called ULA. It's the
Yeah.
Space Launch System with the Orion capsule.
Yes.
It is a consortium of companies that have previously competed against one another, which makes me really glad I'm not part of that collaboration, because that's a lot of
Yeah.
competition going into one project. Um, so this is me speaking as a human being who has opinions,
Hmm.
not representing anybody.
Yeah. It's not like we have any funding from any agencies related to NASA in any way. It's not like we're associated with any kind of NASA funding at all.
so so speaking as a human being who is going to, for the moment, be unassociated with
Hmm.
anything, um this is the slow and thorough and super expensive way
Hmm.
of going to space, where every I is dotted and T is crossed, and it's double checked to make sure that the lines and the dots are exactly lined up the way they're supposed to be. And there's been a lot of concern with all the delays of the project over the years that it was going to get canceled before it ever got completed. But no one has actually showed initiative to kill it
Mm-hmm.
off. And so now we're in this weird place where NASA and SpaceX are essentially in a space race against one
Yeah.
another, except NASA is incentivizing SpaceX while funding ULA. And it's just, I wonder if this is the best use of funding.
Yeah.
But if we get two rockets, one of which is capable of just like casually flinging large spacecraft into space, no big deal, I can't complain with the results.
Yeah, I agree, right? Like heavy lift is a thing we need. No
Mm-hmm.
question that many of the missions have had that in the past have had problems because there's no heavy lift. They've had to do bank shots around the solar system to get the Galileo spacecraft or the Cassini spacecraft because they just couldn't put it on some
Yeah,
monster. Imagine an orbiter that could go around Pluto, not just a flyby, but an orbiter. Imagine
right,
a larger spacecraft that could visit each of the Galilean moons and orbit it and send down, there are things we could do with a heavy lift vehicle that we just can't do right now, and we need that capability. And
right.
there's the Falcon Heavy, which in theory is going to be able to do it, but NASA's place is to be there at the cutting edge of the just the limits of what human beings are capable of doing. The International Space Station costs a lot of money. But it is a marvel of engineering and capability and what it does. And when we build our wonderful rotating O'Neill cylinders, we're going to need heavy lift capability to get that thing built. So,
Yeah.
and then what do you use a heavy lift vehicle for, right? You need to send really ambitious missions out there. Again, push the limits of human exploration. Let's get the same thing. Let's send some people out past the moon. Let's land on the moon. This is how it begins. We need to make sure this rocket is safe. We need to make sure that the Orion capsule is going to do its job, not just as a local ferry boat, but as a tool for getting astronauts way out beyond the orbit of
Yeah.
Earth. And this is how we do it. We can't learn to live in space until we try to live in space. I know that's a tautology, but that's just how I feel. So
And where I end up very torn with this one is it's locking us into a high cost future of, hey, we have a heavy lift rocket. Now we've got to build things that require heavy lift rockets. And part of what has allowed us to make such amazing discoveries in the past couple of decades is the diversity of what we've launched between
yeah,
the massive cornerstone projects, the great observatories that we've talked so much about, but also the little tiny way nothing explorers, the discovery class missions. We need this mix of low cost and high cost that allows us to take risks. If you accidentally lose if you accidentally lose your little Philae lander, it didn't cost that
mm-hmm.
much. You could take the risk,
Yeah,
and everyone cries because it was adorably
yeah.
communicated. But I just want to make sure we don't lose track of the importance of the low cost, high risk missions.
Yeah, yeah. I mean, I feel like if we get to the situation a couple of years down the road where SpaceX is launching the Falcon Heavy and it does essentially everything that the SLS does at a fraction of the cost, then it's going to be really hard to justify continuing to develop the SLS and continue to maintain it. And then you've got that workforce
Yeah.
that then what do you do with them next? And I
Well, and we're
feel
facing this with everything.
right.
I
And
mean, if you think about how our
yeah.
industrialization is changing, we are increasing our productivity so quickly that we need fewer people to do the same amount of work.
Hmm.
And it's not that robots are replacing them, it's that a single human being is now able to use technologies to do so much more work that you need fewer human beings to do the same amount of work, not that you need
Right.
no human beings.
But yeah, I mean, I feel like though it would be sapping the, I don't know, the motivation of the workers, the people working on these, if they knew that what they were doing was really just a make work project to keep them working. Like they
Right.
would be just as happy working on really innovative ion thrusters and Vasimir rockets and nuclear propulsion systems and smaller, more elaborate, more technically risky propulsion systems. And you know what I mean? Like I feel like you could take all of the stuff at the edge, the complicated stuff that hasn't been figured out, and set these as challenges across all of NASA, and the engineers would love it. They love to work on
Yeah.
that kind of stuff and know that what they're working on is really pushing mankind forward. And I don't know, that's my feeling. So I feel excited about the SLS, but I feel a sense of dread about the future of the program as other cheaper, faster solutions come out, and then they're, as you say, they are competing with SpaceX, which is, seems like a pretty tough thing to do. So
Yeah.
I don't know. I'm super torn about that.
It's also a reminder, though. There's from economic theory, we know that pretty much every big business has this hockey stick shape to how it grows and declines, and this comes up over and over and over again. Where unless you reinvent yourself, like Apple did with the iPhone, you're going to decline. And we're seeing a new rise in SpaceX and Virgin Galactic in Blue Origins as we watch the predicted decline of the elder statesmen in the field. And so the question is, what's their new iPhone?
Yeah, yeah. Michael Meyer asks, "Do you think Trump might give SLS money to SpaceX?" Um,
I
yeah,
I can't. No, I have you. The no is I'm not going to try and answer that because there's some things you don't try to predict, and what's going to happen in the U.S. for the next 4 years is not something you try and predict.
right. Um, yeah. Is Trump going to tell all of those workers that they don't have jobs anymore? How would that play out? So it's one thing to say we need to decrease the bureaucracy and speed things up, and it's one thing to stare at
And it's
tens of
Congress that
thousands of
controls the
angry
purse
voters.
strings.
Yeah, yeah,
So as long as Congress controls the purse strings, it's an even more dynamic situation.
yeah. And that's the great thing about me spouting off about this is, again, as a Canadian, not only should I not be given this job, I'm not allowed to be given this job. So
Right.
I can opine pointlessly from across the border. Haven't had the Canadian Space Agency knock on my door yet. So Robert Scott Herrick said this is like a mini episode of Astronomy Cast 2 for 1. I've been thinking about us taking the full episode and making it available as a podcast as
We'd
well.
probably want to do a separate feed, but yeah,
Yeah,
we
no, it
could
would be
do
a separate
that.
feed. So people who just want
Yeah.
the core one, they can. If they want the full feed where we ramble on for the entire hour or so, then we can do
Yeah, it
that.
gets so a few of the podcasts I listen to that are also radio shows that do interviews, it gets really annoying when you listen to the edited version and then the next thing in the feed is the full version. It's like, but I already heard two-thirds of this.
Yeah,
So
yeah.
we're not going to do that to you because it would annoy me.
Well, that's really all that matters. But no, I think we will just have two separate feeds. One being Astronomy Cast, the old school feed, and then
Yeah.
one being uh, the full the full feed, which has all the setup and
Yeah.
the entire sausage making. Probably not video because you can just get that from YouTube, but I like the idea of that being available on audio because I do feel that these conversations that we have are fun and we are answering questions and they're almost as much fun as the episode itself. To me, anyway. I don't know, you folks watching this, I don't know if if this is mildly entertaining. You're still here, so obviously, no one's forcing you. And it also lets me, I think, step out of character a little bit, which,
Yeah.
you know, for people who only listen to Astronomy Cast and they just think I'm that dummy that asks you a bunch of
No,
questions.
you're totally not.
So, but I think that's just me being, um, selfish. Okay, cool. We're sort of closing up to the end of the hour.
Yeah, I have to go get an airplane.
Yeah, no, that's why we're doing the
So
show right now.
it's true.
Thanks everyone for watching us. Thank you, Pamela, for bringing the brain. Big thanks to the Weekly Space Hangout crew for operating this lovely chat down here, and of course the wonderful community that surrounds and envelops all of the work that we do. We've got Dr. Alan Stern on the Weekly Space Hangout tomorrow, where we're going to go toe to toe. And I'm going to ask the tough questions about Pluto. Is it a planet? Is it not a planet? Is the moon a planet? Is this your plan? And propose the idea of the term world. So watch as we do battle. And by that I mean have a hilarious time yakking with Alan Stern about Pluto and New Horizons and all that kind of stuff. It's going to be a lot of fun. Just to let you know as well, someone in the Weekly Space Hangout crew said, hey, I'd like to hear about the Solar Probe Plus spacecraft. Did you know they're sending a probe to the sun?
Oh, yeah, that I do know.
And I was like, okay. And so I reached out to the primary investigator, and now they're going to come on the show. This is how this works. We are just if you see a thing that you want to have happen, just let us know, and
We're better at facilitating than coming up
with the
creative
ideas. Yeah,
Yeah.
like what? Okay, sure. You want someone from LIGO? Done. Like whatever, no problem. I was like, I wanted someone from the LSST, and so I reached out and got one of the investigators from the Large Synoptic Sky Survey to come on the show. So that's really the point of these shows. But anyway, if you haven't already, go to wshcrew.space and join the community, join the Slack chat, have direct access to me, Pamela, and the rest of the celebrities within the community. All right, we're gonna wrap this up. Thanks everyone. We will see you all tomorrow with Dr. Alan Stern.